A nice day to everybody. Thanks for checking out this video. We are now at the third module for our consumer chemistry lessons. Last weeks we learned about the intro for organic chemistry, and then we learned that there are a variety of hydrocarbons everywhere. We have straight chain hydrocarbons, we have cyclic hydrocarbons. And this time, we're also going to learn about a new group of hydrocarbons called the aromatic hydrocarbons. So for today, let's have first a short introduction and a short recall. Second, let's go to the systematic way of naming these hydrocarbons. And third, let's have a short let's get a basic understanding of the different reactions that they undergo to create such a variety of aromatic hydrocarbons. Before we get to the hydrocarbons, let's have a short review. So, our topic for today is related to the cyclic hydrocarbons because they form rings. So let's review on how to name them. What is the first step? Okay, the first step is get to know your parent chain. After you learn about your parent chain, you then start giving the numbers. How do you give the numbers? That is first by looking at the substituents or the different groups that connects to the parent chain. So if you have two or more substituents, what are you going to do? You're going to arrange them in alphabetical order, and then the one with the lower alphabetical order is written first in the long name. Okay. After that, you then write the whole name, adding the word cyclo to your parent chain. Okay, let's try this first. So you can pause the video, and then I will answer, and I will show you the answers. Okay. This one, you have a cyclo. What could this be? It's a cyclopentane because there are 5 carbons. 3, 4, 5. What is there? We have a methyl. We also have it's an ethyl. And what else? Let's start numbering them. What should we give with the lowest number? Because E comes with M first. So let's have our 1 here. And then 2, 3, 4, 5. Again, make sure that your branches get the lowest numbers as possible. So you can go from here to here because it'll be greater number. So let's combine these and then give the name. So the first one, our locator for ethyl is at 1-ethyl. Next, the methyl is at 2. And the parent chain. Okay, did you get your answers right? Okay, now let's continue. I will be giving you the correct answers now. So for this one, we start because there is a multiple bonds are superior than the substituents. So whenever you see a multiple bond, you write the number 1 first here, and the 2 here, 3, 4, 5, 6, 7. So this is actually a cycloheptane. It's a cycloheptane. And this one, this kind of branch, what do you think it is? There's a carbon here. It's attached with 2 other carbons. And this one here, so it's 1, 2, 3, 4. It's a kind of butyl, but what kind of butyl? Because the main carbon here in the middle is attached to 2, so it's a secondary butyl. So it's sec-butyl. So how are we going to name this? So take note that your butyl is attached to the number 4 carbon. So the name is 4 sec-butyl cycloheptane. heptane. Okay, for secondary butyl cycloheptane. So for prefixes like sec and tertiary or third, like sec, there is naturally a dash after them. So you just have to copy them. Okay. For iso, there's no dash after iso, so just write isopentane like in a one-word way. Okay. Number 3. This one is so your branch is, you have a methyl, and this one is this is a propane, cyclopropane, because there are 3 carbons. And to give the branches with the lowest numbers as possible, this would be our 1 here. So this is a methyl attached to the 1 and another branch ethyl attached to 1. So we're going to name this one as 1-ethyl. Write the ethyl first because it comes first, the E, and then 1-methyl cyclopropane. Number 4. This is the parent chain has 6 carbons, so it's a cyclohexane. And then it has 3 substituents. These 3 are similar, so it repeats. So we have the prefix of tri, but what could this be? See? Your carbon here is attached to 3 more. So because there are 4 of them, it's a kind of it's a butyl. But since your main carbon is attached to 3, so then it's a tertiary butyl. So third butyl. To separate the word, the prefix tri to third, you must add another dash. So tri-third butyl. And because there's 3 of them, we can start our numbering at the first branch, so then it gets the lowest number as possible. So 1, 2, 3, 4, 5, 6. So our tertiary butyls are attached at carbons 1, 3, and 5. So your number is 135 dash tri-third butyl cyclohexane. Is it correct? Okay, now number 5. Okay, so we are seeing another multiple bond here. So let's start again with the one that owns the multiple bond, and then you go at the direction that gives your branches the lowest numbers as possible. So we can have it here. Okay. What is your parent chain first? This is a cyclo. Oh, by the way, this is a butyl cycloheptene. So my bad, because it's a double bond. It's an alkene, cyclic alkene. Okay, so here, because it's a double bond, it's a cyclohexene. Then your branches, you have a methyl, you have an ethyl, and what is this? 1, 2, 3. This is 1, 2, 3. This is not an ethyl, but actually a propyl. Propyl. But you have how many? This one here and this one here. So it's a dipropyl. So now let's give the name. First you start with, because it's between M and P, for di you don't have to count the D, because the di is from a prefix, di. So the main word is propyl and between M and P. So what comes first, M or P? Of course it's M, because LMNOP. So for methyl dash 1,3 dipropyl Cyclo. Oh, our name here. Let's write it here below. So it's 4-methyl 1,3-dipropyl cyclohexene. Is it correct? 4-methyl 1,3-dipropyl cyclohexene. Okay, so if you got the correct answers right, very good. So let's try to hold these rules, because these are pretty much applicable to the next lesson. So just a little reminder, many of you may have found this confusing, but this is how you identify on when are you going to use the word third or sec. So for example, you use the third when this carbon here is attached to 3. So 1, 2, 3. So it's 4. So this is a tertiary butyl. For sec, this carbon here is attached to 2 other carbons. So the carbon that attaches to the main branch is together with 2 other carbons. So that's why it's sec-butyl. For iso, what do you think? Your carbon here is attached to just 1. With this one holds another 2. So upat gihapon. This is your isobutyl attached to this branch here. Okay, so just the normal one, then N-butyl. This is just the straight line butyl. So 1, 2, 3, and 4. So this is your N-butyl. Just a little familiarization, but you can really do it. Okay, let's now go to the aromatic hydrocarbons. We learn about straight chain, we learn about cyclic hydrocarbons, but there are also like ring-like structures in hydrocarbons, but are not considered really as cyclic hydrocarbons, but this time aromatic. What could make them as aromatic? So we have a song that we're going to do in class, but I'm just not going to record it here so that it'll save some time. So I will link you to this video, and then you can watch the video for yourself. Is that okay with you? So, and also the follow-up questions, you can answer them by watching that video. Okay. So now let's go to benzene. Benzene is a special character in this lesson because benzene is the idea that started this aromaticity, or the kind of property that is unique to aromatic hydrocarbons. So benzene is the simplest aromatic hydrocarbon discovered by Michael Faraday in 1825. Mr. Michael Faraday. So benzene is a molecule that has a molecular formula of C6H6. So it is a very important compound both in the industry and in the lab. But this one is toxic because in its vapor form it is toxic, as well as in its liquid form it is also very poisonous if ingested. So what is benzene? Let's try to watch this short video from Fuse School YouTube. So I'm also giving you a link for this. Okay, so it said there that there is a special property which is conjugation. Okay, I actually cannot let you watch this whole video here because that is not good, because this whole recording also will be uploaded in the YouTube. So for this ones, for you to continue watching, I'm just going to give you a link at this moment. So you just click that link. It mentioned there that aromatic, the word aromatic, really, when you hear the word aromatic, we think of words like good smell or something that is very pleasant to the nose, but no. So just like before, the term organic has a different technical meaning when it comes to organic chemistry. The aromatic word also is another technical term for chemistry. So aromatic is not really just pertains about the odor. So even many of the aromatic hydrocarbons do not smell good. So not every one of them, not all of them smells good. So when we say aromatic hydrocarbons, so they are, or aromatic compounds, it's any compound that has one or more benzene-like rings. So another name used for aromatic compound is arene. So within that ring is this conjugation of electrons. So for example, we have our benzene ring. Let's have a benzene ring like this. So the unique characteristic of a benzene ring, let's just write our H for emphasis. Okay, so your carbon here, there is to complete the capacity of the carbon to hold bonds, there is a double bond alternatingly inside, but within that ring, actually the electrons just move around, are free to move around. So just like what you have seen in the video, there is a process that is what they call conjugation. So they tend to like hybridize. So if you see benzene drawings which also look like this, the drawings, the double bonds are at a different position, it's just equivalent. So because in real life, inside that molecule, the electrons are freely flowing inside, so more like they just share. So in other books also, that is why you can see my drawing is erased. So you will see in other books there will be a drawing of like this. Okay. Again, aromatic compound, when we say aromatic, not really about good smells or strong odors, or also pleasant ones and also not pleasant ones, but also the property of the compounds which have benzene-like rings. So benzene-like rings, they have a conjugation of double bonds or conjugation of electrons inside the ring, and yes, they're called arene. Okay, so back then, Michael Faraday proposed about this benzene, but the model is not yet final. So we have this Mr. Friedrich August Kekulé, and he proposed the first structure of benzene. So it consisted of 6 carbon atoms with alternating single and double bonds, and in each carbon atom 1 hydrogen is bonded. So according to some stories also, he had this idea in a dream, wherein he dreamt of a snake eating its tail. So cyclic also. So here we can have this complete structural formula where the H are shown, the ball and stick model, and also the line angle formula. In the line angle formula, the H now is not written, just like what we did before. Ang line angle formula does not show the H. So you can have this, or you can have also this, where there's a circle inside your benzene ring. So when benzenes lose 1 hydrogen, so that means they can connect to other kinds of groups of substituents. So that is what we call an aryl group. It's a group derived from an arene or a benzene or an aromatic hydrocarbon by the removal of an H atom from an arene, and it's given the symbol -AR. Okay, and this R here stands for, what is it again? It's an alkyl branch. So you can have methyl, you can have ethyl, and so on. Okay. So resonance structure of benzene. We have this what we call the theory of resonance. So we have mentioned this idea of conjugation, but this is more clearly explained in the theory of resonance. So Mr. Linus Pauling in the 1930s, he proposed this theory of resonance, stating that certain molecules and ions are best described by writing two or more Lewis structures. So we can have the bonds here. We can draw it like this, or we can draw it also like this. So the real molecular ion is a resonance hybrid of these structures, each contributing structure. So this is shown by positioning a double-headed arrow between these two. So we can have either this or this, because in reality, inside the molecule, and the electrons just move around inside. So your benzene has unique properties as well. So they are usually stable because they have a lot of double bonds, and also only one H-rich carbon, and then their shape is planar, flat, cyclic. It's a closed chain, and then there's a hexagonal structure. Okay, it's a hexagonal structure resonance hybrid, a molecule best described as a composite of two or more Lewis structures. So combination. So either one of these two. So it's usually volatile also, and it's toxic or poisonous. Ano siya ang mga properties of this benzene and also the aromatic hydrocarbons. So we have notable aromatic compounds around us. So all of them could not smell good. Some of them smell strong. Some of them have a distinct taste. So look at this first picture. So this is sili. So this is an example of an aromatic compound. Inside this, the compound that makes the peppers and the chili give you a burning sensation when you eat it in your mouth, and suddenly kanang kalwaon ka, like that. So muna siyang compound na gitawag na to nga capsaicin. So look, there is a benzene-like ring in it in the first part, and then there's a tail na naay mga other components. We also have the hormone that is produced in our thyroid gland, which is the thyroxine. Notice that in the thyroxine, duha, looks like two benzene rings in its structure. So thyroxine is a hormone synthesized in our thyroid gland, and this is essential for the normal growth and development in mammals. Okay, and this one, have you seen this type of plant elsewhere? This is what we call a poison ivy, and the poison ivy has this main component that makes it irritating when it touches the skin. Mangatol ka. Ang tawag ani nga compound, this is the urushiol. So yeah, it causes severe contact dermatitis in sensitive individuals. So especially when your skin is very sensitive, those people easily dali ka sa mga tol, mamula, labi na pa jud kutkuton. So look at this structure here. Muna siya na head na ring, and then na siya long tail. Next, we have the vitamin E. So most of you have heard the vitamin E in mga advertisements. So this is a natural antioxidant. So alpha tocopherol yung name. So naa siya ring-like structure po also niya, long po yung tail. Also, we have this thymol, an antiseptic compound that is found in toothpaste and mouthwash used to reduce plaque and gingivitis. So naapod siya sa mga toothpaste. Also this one, the vanillin. So naka-try na mag-baking sa inyo, or kanang gamiton gani magluto ba ito ng cake or mga torta, paano din yung lula na papalit ito og vanilla. So kani siya nga vanillin, this compound is also an aromatic compound. It is widely used as food flavoring, usually used to increase the milk flavor in desserts and sweet foods. So, kaning next examples here, mga food coloring compounds. So, ginaan siya sa mga food coloring and it gives us mga artificial taste and color. Just like this, Allura red and sunset yellow. Okay, let's now go to the nomenclature. So, how are we going to name these aromatic hydrocarbons? So, when we say aromatic hydrocarbons, they have this benzene-like structure in their components. So they can either have one substituent, two substituents, or three or more substituents. Okay, for one substituent, derivatives of benzene are monosubstituted alkyl benzenes. So benzene is a parent, benzene is your parent, and there is the alkyl branch that connects to it. So for example, this ethyl benzene. So your benzene is here and your ethyl is connected to your benzene. So this is what you call an ethyl benzene. The IUPAC or the IUPAC system keeps certain common names for several of the simpler monosubstituted alkyl benzene. So naabot tayo mga special names. We just have to familiarize a few of these. So we have this benzene with just one methyl. So this is what you call a toluene. If ethene, that's what you call a styrene. The OH connected to this, mo ni siyang gitawag nga phenol. So you have a hydroxyl branch. So OH, ang OH ni connect. So phenol. We have anisole and we also have aniline. So common po siyang aniline. In the aniline, the parent is benzene, but we have this branch of NH2. Okay, remember lang aniline, toluene, phenol. And also we have benzaldehyde, C-double-bond-OH, and benzoic acid, COOH. So take note the first benzaldehyde only have this one. The carbon is connected with an OH, and this one. Your benzoic acid, your carbon has a double bond with an oxygen and another hydroxyl group pair. So benzoic acid. Okay, benzoic acid. Just remember benzoic. There's oic in its name. Okay, again, toluene, phenol, aniline, benzoic acid. We also have times when the halogens connect. So whenever halogens connect, we have names to give them. For example, what are those halogens again? We have fluorine, we have chlorine, bromine, iodine or iodine. Okay, so if it appears in the structure, we name it as fluoro. Bromine and iodine. So we can have for fluorine, it's termed as fluoro. Chloro for chlorine, chloro, bromine, bromo, and iodine, iodo. Okay, just simple terms. Okay, just remember fluoro, chloro, bromo, and iodo. Okay, next. And then after our monosubstituted or one substituent only type, we also have, let's go to the example first. So this is also a special group, which is the phenyl group. Basta mura na siya benzene nga. This one is free to connect with any type of mga groups. Okay, sometimes when you have phenyl group, the name is, this phenyl becomes a branch for a substituent. For example, na kay propene chain. 1, 2, 3. Propene. This is a propene here. And this one, the whole compound here, kay mo na din siyang phenyl. So, the name would be, because your one starts here, kaya naman diri mong double bond. So, 1, 2, 3, your phenyl is connected to the 3. So, 3-phenyl-1-propene. Propene. Like, also for this one po, naatay kuan diri, cyclohexene. This is a cyclohexene, the one that is written in the box. And then, this one, familiar structure, parehan is, mauni siya si phenyl. So, it's a parent molecule, and this phenyl is the parent molecule, and then the other one, the cyclohexene is your parent molecule, and the phenyl becomes your substituent. And there are those times nga mahimo siyang substituent. Next, two substituents. So just like in the song, we have there are 3 names, but before that also, basta duha gali ang substituent, there are two ways to name aromatic compounds. The first one is by assigning numbers to the carbon atoms of the ring to locate the substituent. So just like before, we assign our numbers 1, 2, 3, and so on. So make sure gihapon nga your branches have the lowest numbers as possible. So also this one put 1, 2, 3, 4, 5, and 6, and 2, 3, 4, 5, and 6. So we assign numbers. Or the other way is to use this Greek words locators, ortho, meta, para. Ortho, meta, para. So ang ortho, it's for 1 and 2. So right after ang basta mga branch kini mo gasunod, that's ortho, or O dash lang siya kung i-write sa name. If naisap ang usa, meta, M dash. If naisap ang duha or gatubang siya like here and here, sa imong cyclic ring, sa imong benzene ring, it's para. So basta atbang para. Okay. For those two substituents where one has a special name, we name the compound as a derivative of the parent molecule and assume that the substituent bearing the special name occupies ring position 1. So what does that mean? Whenever one of those two parts kay maka-form siya og muna ay mga special name, mao to ang gamito nimo as parent, and the other one becomes a branch. We will have an example of that. Before that, I've mentioned the word derivative. So what is the meaning of the word derivative in chemistry? So we have another meaning for that when it comes to mathematics, sa calculus, but not so much for that. So at sa chemistry, so observe. This is a phenol. Yung phenol nimo na OH. Toluene. Benzene. It's a benzene ring, but this part is a methyl. This is aniline and benzene still, but here it's an ammonium. So muna ginana siya anisole also, lahi sila mga structure here. So when we say derivative in chemistry, let me erase that one. So in chemistry, a derivative is a compound that is formed from a similar compound, or a compound that can be imagined to arise from another compound. If one atom is replaced with another group of atoms, the latter definition is common. So ang pasabot ana kay ang kaning derivative mura siya og kuan gikan or nag-arise siya from the original one, unya giilisdan lang siya og some parts, like here benzene ang body nya basta kuha usa, so phenyl group, phenyl nya gini-attach og hydroxyl, phenyl attach og CH3. Ang phenyl kay motor siya ang benzene na nakuha og H. Okay, so derivative murag lain-lain nga version ba. Lain nga version sa phenyl, so lain siya attach. Okay, let's continue. So let's try to name these two examples. So first, try to look at if na ay special name. And then if there is a special name, your special name becomes your parent. And your numbering, the number 1, carbon number 1 starts here, starts at the branch of the parent. Okay, is at the branch of the parent. Okay, and if there's no special name, then you start numbering by the one with the lower alphabetical order. So kani, the ones that are boxed, if we will try to look at our list before, the COOH, ang COOH di ay kay, look at this one. So kaning COOH mao ni siya si benzoic acid. Okay. So let's go back to that. So this one, identify nato na tayo benzoic acid. What else? There's a branch and we have bromo. Kay bromine, so bromo. Dash bromo. So the branch first to ikapila man nag number 1 ta diri 1 2 3 4 so 5 6 so 4 bromo benzoic acid. So special name ni siyang benzoic acid. So 4-bromobenzoic acid is a name. We also have another way of naming this one. So since it's the branch is at COH at 1, yan na diri sa ang bromo niya kay nasa atbang, so that is para. So you can have P dash bromobenzoic acid. Okay. We can have 2 names for this one. Here, second example. So again, look if there is a special name. Step 1 jud, tan-awon if na special name. So if natay NH2, in our example, this is actually aniline. So NH2, si aniline. So if you have aniline, muna itong parent, muna itong branch kay C, with Cl, this is chloro. So if you write that, ato ding numberan. So again, branch of your special nga compound or special nga name, siya mo yung number 1. So 1, 2, 3, 4, 5, 6. So your chloro is at 3 chloro. So to write the name, 3-chloroaniline. Or we can have, because it's at 1 and 3. Ang sakit ang 1 and 3, it's again 1 and 2. This is ortho. 1 and 3, this is meta. And 1 and 4 are at bang para. So for this one, we have meta. So just use M dash chloroaniline. Okay, did we get our answers correctly? Yes. So 4-bromobenzoic or para-bromobenzoic acid, 3-chloroaniline, and M-chloroaniline. Now let's continue. Let's have another example. In another case where neither 2 substituents imparts a special name. So if no special name, locate the 2 substituents. And so same gihapon. List them in alphabetical order before the ending benzene. So alphabetical order plus na ay benzene. So the carbon of the benzene ring with a substituent of lower alphabetical ranking is numbered 1. Again, ang carbon sa benzene ring nga ang substituent niya may kina-lower alphabetical order, kung i-arrange nimo, siya may magsugod sa number 1. So, just like this, we have we have toluene here, di ba? Kay special man yung toluene. But if we can also have another way of naming this. So kung ato ni siyang sugudan sa 1, 2, 3, 4, 5, 6. So actually duha atong methyl. So first na atay dimethyl. Dimethyl ang atong dimethyl kay naa siya sa 1 o sa 3. Yeah. You can have basta inaani mo pagka-write nga no special name. If no special name, use the plus benzene version. Oops. Use the plus benzene in its name. Okay. If no special name, use the plus benzene. So 1,3 dimethyl benzene. And because it's 1,3, again we can have meta. M-dimethyl benzene. But if we just identify the one that is boxed, this is toluene man pod kaning gi-box. So the one that is written in the box. This is toluene. So you can also have, if this is your toluene, so you can write here 1, 2, 3, 4, 5, 6. So pwede ta og 3-methyl toluene or M-methyl toluene. Yep, we can have that kind of naming. For this one also, we can name this one ethyl. This is an ethyl. And this is a chloro. And then we will start our numbering here at the 1. Kay, kuan man siya, letter, let me change my pens first. Again, so if we just use the ordinary naming, let's have red. Okay, if you just use the ordinary naming, this one here is an ethyl. And this one here, chloro. So, let's start with the one that has the lower alphabetical order. So, C man, letter C versus E. So, arita mo sa 1, 1, 2, 3, 4, 5, and 6. So, you can write 1 chloro dash 4 ethyl, 4 dash ethyl benzene. So, your benzene version, so ani siya, basta mag-use ka sa ordinary naming na ay word na benzene. But if you can find a special name, just like the ones that are placed here in the box. So this one also, according to our list, kada siyang gi-box kay ethyl benzene naman po siya dito. So you can still have your ethyl benzene. And if this is your ethyl benzene, then your one starts here, 1, 2, 3, 4, 4 chloro. One name. But actually, ang mas sakto jud ni imong chloroethyl kay this is actually not a special name kaning benzene. Not really a special name. So, you still have to arrange your chloro and ethyl. So that's why if mo ni unahon nimo ang numbering pud nato kay dako siyang number kaysa here. So make sure you have lower numbers as possible. So this is more correct. So if you convert that with the meta and para and ortho, that would be like, what is, 1 and 4. 1 and 4, that is para. So you can have para chloro ethyl benzene. Okay. Here is also another example. This is the correction, for example. So there is also another name pa jud. Silene is another special name. Ang silene. So si M-silene. This can be M-methyl toluene or M-silene. Methyl toluene is named as silene. Okay. 3 or more substituents. We can also have 3 or more. So in aromatic compounds containing 3 or more substituents, identify their locations by assigning numbers. If a substituent is a special name, then the parent molecule is a derivative of that substituent. Again, kung na special name, mo na itong i-consider o mga parent name. And also, when assigning numbers, always start at a site that gives the first substituent of the lowest number as possible. Should there be a substituent of the same number on either side, start from the side of the substituent with a lower alphabetical order. So, mao gihapon, lowest numbers as possible ang kina-lowest sa alphabetical order. Let's try to answer that one. Okay, so kanim. Kita kang example, tanaw ni mo gihapon kung is there a special name? So CH3, and ang NO wala special name, ang Cl wala. This NO here, NO2, this is nitro. The name would be nitro. So we have kaning nga gibox. This is, what is it? Toluene. Toluene, and then we have nitro. We also have chloro. So, when we have our parent molecule, diha magsugod itong 1 sa iyang branch. 1, 2, 3, 4, 5, 6. So, your nitro or chloro, what to write first? N versus C. So, chloro ang una. So, 4 chloro dash 2 nitro toluene. Okay. Next. How about this? Na mangita jud ka kung naa ba special name. So OH. Kani nga nay OH unsa ganito nay hydroxyl group. This is a phenol. So you have a phenol. And then, naa kay mga BR o BR. So, naa kay bromo. Pero, tuluman ka bromo. So, that's tri-bromo. And then, let's start writing the numbers. So, again, kung asa ang branch na imong parent, di ka mag-1. 1, 2, 3, 4, 5, 6, so on. So, pwede po ka diri magsugod. Parehas naman po ng numbering. Like 1, 2, 3, 4, 5, 6. So, equivalent lagi hapon kay alternating man ang position. So, your bromos at the blue will have the numbers of 2, 4, and 6. Yeah. Whereas kung red, sa red nimo kay gyapon 2, 4, and 6 gyapon, so same. Okay. To write that, let's have the name of 2, 4, 6, tribromo. Again ha, don't forget this prefix. Example, multiple gani siya. Don't forget the prefix. So 2,4,6 tribromo phenol. And no benzene here because natay special name. So no benzene when there's a special name. But if there's a no special name, use the plus benzene version. Okay, we got our answers correctly. How about this? In this special example also, by the way, I think I really did a mistake with the discussion of this one during our class. So in having these kinds of branches, sometimes you have to consider which one would get, dapat i-arrange nimo nga as smallest number as possible. So how to do that is we would try to arrange them with a numbering. So first, try na to, kaning green. If this would be your first one, 1, 2, 3, 4, 5, 6. So, dili ka mo agi diri, no? Because, mudako na po imong numbers, ikabot nimo sa NO. 5 na niyan, 6 na niya siya. So, no. So, ato lang yung experiment sa kung asa ang smallest nga numbers as possible. Next. By the way, first, let's write our substituents. Atong mga substituents, kay we have nitro, we have bromo, we have ethyl, or alphabetical na to daan. Bromo, natay ethyl, natay nitro. So what combination will give them as a smaller number as possible? Okay. So dili ta mag-use atong, do not use the ethyl benzene name kay kuanto siya kanang dili man jud siya actually special name. Okay, ari sa ta sa murag ordinary naming. So identify atong substituents. Yang atong parent name kay kuan na siya. This is just a benzene with branches. Benzene or a phenyl. So benzene. So bromo, ethyl, and nitro. If you write the numbering this way, sa green, 1, 2, 3, 4, 5, 6, inana. So our numbering sa bromo kay 2, ang numbering na to sa ethyl kay 1, unya sa nitro is 4. So 2, 1, 4. If we have another way of writing the numbers, so if mag-start ta ni bromo, 1, 2, 3, 4, 5, 6 ni nato. So, ang atong numbering ni bromo is 1, ang ethyl na to kay 6, wag ang atong nitro kay 3. Next, if we have, let's use another color for, if we want to start with nitro po, pwede sa ta 1, 2, dili ta mo tuyog dito ha kay, no, kay mudako jud imong numbers ikabot nimo diri. So, 1, 2, 3, 4, 5, and 6. So we can have your bromo is 4, your ethyl is 6, and which color are we looking at? It's the blue. So your bromo is at 3, your ethyl is at 4, and your nitro, kaning blue nga nitro kay 1. So, how to know if lowest number is possible? We'll give a sum. 2 plus 1, 3 plus 4, 7. 1 plus 3, 7 plus 3, 10. And 3 plus 4, 7 plus 1, 8. So, the smallest combination yielding to the smallest sum, kani. So then our name would be 2-bromo. Let's use the green. 2-bromo methyl for nitrobenzene. Okay. So smallest numbers possible. Right here. Again, trial and error gyapon. Also, we can have not just really substituents, but repeated benzene rings. So that is what you call polynuclear aromatic hydrocarbon or mga PAHs. So polynuclear, daghan yung nucleus din, or mag-center niya ba? So mura siya gi-combine nga benzene rings. We have naphthalene, duha. Anthracene, tulo. Phenanthrene. Mura siya gihiwi nga porma sa anthracene. So each pair of rings share two adjacent carbon atoms. So dire na siya ga-share. Now let's have a clear see here. So the most common PAHs are naphthalene, anthracene, phenanthrene, and substances derived from them are found in mga coal tar or high boiling petroleum residues. So, sila ang top 3 nga mga common, and of course, I think nakadungog na mo ning word na naphthalene. So, naphthalene katong ibutang sa tong mama sa mga sanina para dili makuanan og uk-uk. So, kato siya nga mothballs. Medyo humot pud ni siya sa una kay ako po ning simot-simot. Sige. Ang mothball kay this is a kind of kanang local mga gamiton sa balay nga para pangwala sa mga insects nga mo do sa sanina iulubong sa mga cabinet o sahay. But actually when this para-dichlorobenzene was discovered, which is also another version nga parehas siya function sa mothballs kay medyo nahinay ang business sa taga mothballs kay kani siyang para-dichlorobenzene kay gimix ni siya sa kanang mga spray gani sa ato kanang mga Lysol, mga Glade para pud makapahawa sa mga insects. So nagkusog karon kaning para-dichlorobenzene. Okay, reactions now. So as summary, your aromatic hydrocarbons can have one substitute or have two substituents, substituents, 3 or more, or you can have repetitive rings, just like your polynuclear aromatic hydrocarbons. So all of this variety happened because the chemicals or the molecules and atoms arrange themselves in such a way. But before this arrangement happens, this is supported by a chemical reaction. A chemical reaction, that is when your molecules are in such a they seem to react to one another because of their properties nga. They tend to combine, to rearrange, or to break apart muna siya sa chemical reaction. So we now will learn about the basic reaction mechanisms of the benzene kung sa iyang mga gi-undergo. So first, let's have a review of what the chemical reaction is. So all of these things around us, the processes in our body, the digestion, all these are products of chemical reaction. Also, we have a firework. A firework is a very good example of a chemical reaction. Kung siya decombust into baby or a firework. Okay, so when we say a chemical reaction, it is one or more reactants or your starting materials are converted into another mga products. So, ang imong naa kay reactants ko no, reactants. They yield to products. So, chemists write them in chemical equations. Chemical equations. So what you call a chemical equation? So you can have A plus B, nga mapurma siyang C bakaron, or you can have A plus B, mapurma siyang C plus D, pwede. So one or more products. So chemicals will tend to combine, they tend to rearrange or break apart. So, in any of my examples sa chemical reactions. So, the following slides, we will not really go deeply to the technicalities of a chemical reaction. What I want you to understand is the conceptual mechanism sa reaction nganong napurma katong mga kuan ato, mga benzene derivatives. So benzene, ang aromatic hydrocarbons, they undergo aromatic substitution. When we say substitution, the hydrogen atom, ang hydrogen atom of an aromatic ring is substituted by another atom or a group of atoms. So substituted, napulihan or nailisdan, ana na siya, na inipuli niya nga lain. So katong nga common nimo nga benzene ring, naman to na namatay H or around each carbon has one H. So either one of these kay mapulihan siya, so i-kick out siya, and then ilisan siya o group, another group. So we can have all those kinds of connections here. Kani ba karon mailisan ba ni siya substituent ka mga phenol, mga ethyl, mga methyl, and so on. So mga alkyl substituents. So anything nga pwede nimo i-add diha. So gisubstitutan siya. So the first one is halogenation. Halogenation, there will be halogens. Benzene. And siya. So halogens, we have halogens like katong FCl-Br ug I, especially chlorine and bromine. They react with benzene in the presence of an iron catalyst such as FeCl3 or ferric chloride. Let's have red. So you will learn to name this as you go with your other study of chemistry. So for now, that's ferric chloride. So by the way, your catalyst. A catalyst is a substance that aids in the reaction. That speeds up the reaction. Without really contributing or interfering with it. Really, the reduction of products. Okay, so that is like a conceptual meaning of the catalyst. This is just it just returns to what it is. Ferric chloride naghihapon siya all throughout. Dili siya manghilabot sa reaction, but makapaspas siya because na siya ibang property nga mapaspas siya ang reaction, like ma-remove ba ron ang mga ions and so on. So in this reaction, you have our ferric chloride. So in a reaction, we can add our catalysts here para mapaspas imong reaction, pero ang mapurma A, B, C, ug D ragyapon. Okay. So without a catalyst, the benzene will not react with halogens. So sometimes pugsunon ni si benzene. So kaning mga halogens need siya og catalyst. So ang common nilang catalyst kay si ferric chloride. This is an example of a chlorination of benzene. So another YouTube video which I will try to link because makapirate maguda kay YouTube within YouTube. So may kumputang benzene. Chlorination of benzene. You can watch this video here. Ato na siyang ikuan gamay, play gamay. Okay, so this is your chlorine and the ferric chloride as your catalyst. Pag abot sa ferric chloride, ikuha niya. Because Cl2, ang chlorine ni mo 5 man. Agi man siya. The atomic. So naa sa benzene, ang chlorine ni mo nga isa nabili ni combine. It's actually raining now. So Kanina'y akong tin. Okay, just watch. Na carbolocate ang mga double bonds. Adjust siya kay na puno nga bag-o. Yan ay nag-form na bag-o nga double bond o hawa ang sa kabuok hydrogen. And then apil siya dito sa usa nga chlorine, hydrogen electron, and that's it. So the form of hydrochloric acid nagyapon sa perchloride, but this time ang imong benzene kay chlorobenzene na. Okay. Thank you so much for that video. I-link dyan ako sa description ng mga video. Okay, so halogenation. Halogens like chlorine and bromine react with benzene in the presence of an iron catalyst such as the perchloride and substitutes a halogen for an H atom from the benzene ring. Without a catalyst, the benzene will not react. So this one. This H here is replaced by a chlorine. So natay benzene and chlorine. And then the Cl is now here. And then nag-ili sila. Duha man ni ka Cl plus Cl kay Cl2 man. So ang usa nga Cl na habilin diri, siya na pwede gunit sa usa nga H. So ang chlorine and chlorine. So and all together this is chlorobenzene. Chlorobenzene and then kani nga usa nga product kay si hydrochloric acid. So also with bromine. So same way, perchloride ang gigamit anya ang bromine kay mao gyapon results to bromobenzene and ang habilin ni mga B HBr, so hydrobromic acid ang okay. Just concept lang ato ang imanan ani. So ang halogenation, one H is replaced by a halogen. Next. So, we have an example. Another example also is the reaction of chlorobenzene and the bromine gas. The result is three products. So, what if ang atong chlorobenzene diri kaniha kay ato pa jud ma-react na pud usab. So, we can have chlorobenzene plus another bromine. So, makaporma ta og disubstituted. Two substituents. So, tulo ka ang possibilities. You can have just like this, ang BR ni mo na dire, or you can have one bromo or meta. You can also have the para arrangement. This one ortho. Kay animan, nagsunod sila. Kani kay nagsapang busa, kani kay nag-atbang din sila. So, three arrangements. Same gyapon. Ang chlorobenzene, basta kung ano mo bromine, ang forma kay kani in-ani siyang arrangement or in-ani. You can have ortho bromobenzene, bromo chlorobenzene. You can have the meta or the para bromo chlorobenzene. Okay. Next, nitration. So after with halogenation, you can have nitration. So in nitration, naatay nitro group. Not NH group, not nitrogen. Not NH. Not NH, but nitro. Nitro means nitro dash NO. This is blood red. So weird. Okay. So a nitro group replaces one of the hydrogen atoms in the benzene ring through heating benzene or one of its derivatives with a mixture of concentrated nitric and sulfuric acid. So you can have this sulfuric acid as your catalyst. Parang paspas ang reaction. So sometimes magod if ang mga chemicals if imura na siyang isagol diha sa like isagol nimo sa kasundanan, dili na sila magtagal like okay ra. Dili sila form of heat or mag-mix, explode, and what other imaginations you can think of. Especially kung dili nimo siya sugdan, like imo ba siyang butangan og catalyst or imo ba siyang initon og gamay. So that is when your electrons they tend to be excited and lihok sila hantod magbaga na yung mga molecules with another molecule, and that is the one that starts your chemical reaction. So muna nga, in this process need gyapon ta og catalyst. So yung benzene, kung andaw nimo o nitric acid and HNO3, you can form what do you think? Form na to kay. Let me draw first. It's raining. Your benzene now connects with a nitrate. So, mauna nga, HNO. Plus, so this is your minus ni mong NO. So, ang nabilin kay H na lang ko. Kita naman, napaman kay sobrang nga H. So, nakaform siya H. Na siya water. So, nitrobenzene is formed. And water. Yeah. So, that is nitration. So, conceptually lang dyan ha, your hydrogen is replaced with a NO2, nitro group. This is in the process of heating your benzene together with the catalyst nga sulfuric acids, mga nitric acids po. Form ang nitrobenzene and water. We have halogenation, we have nitration, we also have sulfonation. Si sulfonation na kay arene sulfonic acid, sulfonic na, with space na nila, arene is formed by heating an aromatic compound with concentrated sulfuric acid. So this time, makapurma ka og sulfonic acid na arene. So let's not go complicatedly. So ano siya, makapurma siya ang imong SO3. Ang SO3H, this is sulfonic acid. Combine siya sa mong benzene, that's why it's called benzene sulfonic acid. And the remaining ones, combine siya o sa ka-H o na IO na bilin of another H, so H2O or water. So again ha, conceptually lang sa kita, benzene, sulfuric acid, kanya, ma-form ka og benzene sulfonic acid and water. So this sulfonation is a common process that is also used in make of mga detergents, mga compounds sa detergent. But just remember nga, sulfonation is used in the production of mga synthetic detergents. Used in the production. So next and lastly, napod siya possibility nga ang imong benzene or ang benzene with OH, what is a phenol? This is what you call a phenol. Benzene with hydroxyl group. Katong OH. What does it look like? Nakay? OH na branch. So they react with strong bases to form water-soluble salts. So NaOH is what you call a sodium hydroxide. So phenol plus sodium hydroxide. Makapurma ka sodium henoxide of water. Again, conceptually lang sa taglit. You will not really be more technical with this unless we go to the reaction lesson. But as long as wala pa ta dito sa ta, kaya we need a lot of basics before we go to this one technically. Okay, so because of those different reactions, the sulfonation, the phenol reacting with mga strong bases, the halogenation, the nitration, benzene was able to make a lot of derivatives in organic chemistry. So we have these examples here which are very common. Kaning na ay red na circle na sila halogen. Kaning na ay blue na siya hydrocarbons. So you can have an alkyl group, methyl, isopropane, kanipot, isopropyl ay the benzene. Would also have oxygen containing. So the most famous ones, if phenol, we also have the benzoic acid, the benzaldehyde. We also have nitrogen containing, the ones in pink. So here, so aniline, ang NH2, ang NO2, nitro, benzene. Yeah. Benzonitrile, and so on. Sulfur containing, also this one, benzene sulfonic acid. Muna siya ang naporma kanina sa sulfonation. So just remember, this is a benzene sulfonic acid. And polyaromatics, or katong polynuclear hydrocarbons, mga naphthalene, anthracene, mga phenanthrene, and so on. So because of this ability of the benzene to be able na ma-ilisdan siya, o ma-substitutan siya, we're able to have this variety of benzene that is useful sa industry, sa mga pagkaon, sa mga plant parts, sa body school. That is why ang aromatic compounds is also an essential part of almost everything here on Earth. So that is why it's also very important to learn about this. So that's it for today. Here are the things that we have learned. So we have the introduction about the benzene. We also studied about the naming, and then we're done with the basic mechanisms of substitution reactions. So hopefully you're able to get those concepts before you go to your activities. So first, again, aromatic compounds, they have this benzene-like structures in them. And then, naming niya, you can have the special names. You can have special names. Names as parent. Or the plus benzene version. Atong with numbers. So, again, similar again sa progress sa una. So, we also have the substitution reaction. We have halogenation. What else? Nitration. We have sulfonation, which is a hydrosulfonic acid. Or benzene sulfonic acid. We also have phenol reacting with other strong bases. Okay, so you may now continue answering your activities. And again, I really appreciate everybody's effort of watching this video and trying to learn again. Let's all learn together, because I am also learning food what I teach you. So thank you so much for watching this video, and practice and practice and practice na dito siya food. Okay? We have a lot of rules, but those rules become simple when you get used to them. Hindi mo na siya muscle memory. So chemistry is not a spectator sport. Ato siya tanawon. So the more we engage in naming and drawing, mas maanan na ta. So laban na.